Welcome. My name's James Wormold. I'm a writer here at Europa Science, publisher of Electro-Optics. In this web panel, we'll be discussing how industrial users can enhance the optical efficiency and the accuracy of their systems with advanced optical design software. Optical design software is no longer just an option, it's now mission critical. Whether you're engineering high-precision lasers, simulating illumination systems, or tackling any other optical challenge, using the right tools can make the difference between a working prototype and a breakthrough product. In this session, our invited guests will explore how modern optical design software platforms are transforming the way engineers, OEMs, and researchers develop cutting-edge systems to improve accuracy, reduce time to market, and expand what's possible. Joining us to share their best practices, real-world insights, and practical tips on simulation, optimization, and performance validation are Tom Pickering, Product Manager at Ansys Zemax, Chris Maloney, Managing Director of US Operations, as well as Director of Business Development at VPI Photonics, and Dave Jacobson, Director of Sales and a Senior Application Engineer at Lambda Research Corporation. Welcome, gentlemen.
Thank you so much.
Welcome. Thank you.
Before we begin, I should point out that this discussion will be available to watch on demand alongside others in the Electro-Optics Photonics 100 series on the webcast section of the Electro-Optics website for 12 months after today, in case you'd like to recap any of the information. Speaking of the Photonics 100, by the way, now that I've mentioned it, the nominations period for 2026 has been extended to Monday, 14th of July, so make sure to nominate all your photonical heroes before then. Back to today's discussion. I'll start off the conversation by throwing over some questions for our speakers to answer, but please do write in using Zoom's Q&A tab at the bottom to submit and have your own questions answered. No subjects too niche. And if you're listening on demand, then you can still send them over to us anyway, and we'll forward them on to the relevant speakers at that point. But right now, I can sense our speakers are all ready and raring to go, so let's get started. Question one. So we have a lot of optical engineers and researchers watching. What advice would you give them about how best to utilize optical design software platforms in their pipelines? Maybe Chris, if you could kick us off with this one, please.
Yeah, I can get started. And I guess this goes for optical design software in general. But the first point really is to make the case internally, right? Does your team, there's a decision to be made. Does your team want to spend the time developing your own internal software, have a team of people working on it, spending their time developing it, updating it, maintaining it over the years? In some cases that might make sense, but it's typically actually less expensive, less time consuming to go with to buy commercially available software and then customize it as needed. Because then you benefit from a number of things, right? You get regular updates to the software, you get access usually to a support team. So oftentimes you have a support team in the background where you can, if you're just one person working on a design, you have a team of, 10, 12 people that you can go to for help. So that's really the first point, is make that case internally if you want it to be developed, but then also realize there's a bit of a learning curve, right? So with all of these softwares, it's definitely about what capabilities are available to you and does it solve your problem. But it's also about the team you're working with, right? So I know a lot of the software vendors, we have close personal relationships with our users. So do you have the solid contacts there? Do you have trust with the team? And is the support team competent and responsive? And if you have that part, you should also make sure, are there training opportunities available? And it's not always just the software, and that's really something that a lot of people it takes time to realize, but it's the team behind the scenes that come with it as well. So that's some advice for those getting started trying to bring software into their teams.
That's Chris. That's good advice. No software is an island kind of operating by itself. And Dave, have you got any additional nuggets of advice on the
Sh-
integration of multiple
Uh,
station technologies?
sure. I mean, that's Chris's points are a lot of really good ones, especially getting that initial buy-in. A lot of times it's good to try different software as well. In a lot of these applications, there's different options. Uh, try what works well. I tend to find that there's a lot of, at least in our field of things, more of the geometric ray tracing side of things. There's a lot of overlap, but there's also some specialties, some things that some programs do really well, some that other programs, maybe don't do quite as well. So there may be some nice synergy or alignment with one package versus another. Uh, uh, we do a lot of teaching as well. So we used to run a lot of in-person classes, but when COVID hit, a lot of that dried up. But we found a nice niche now of doing online training and doing a lot of web-based training, and which allows us to keep the cost down. We can educate a lot of people in a lot of time, in a relatively short period of time. The thing I always like to stress, especially when people are new to software, you know, is one thing is first of all, don't be afraid to make mistakes. As a matter of fact, it's better to make your, I always say it's one of the taglines I use, and whenever I give a talk is make your mistakes in software. It takes less time and it takes less money, more importantly. Previously, I was on the hardware side of things as an optical designer, and it was a lot of I would design something and before I had software, was doing it in like AutoCAD or on pencil and paper, and then bring it into the lab, measure it, figure out what you did wrong, or actually before you even went into the lab, go into the machine shop, make it, bring it into the lab, test it, figure out what you did wrong, and then iterate through that whole process. And you don't realize that the amount of time and money that takes. And then the one other quick thing I'd want to add, and this came up with a conversation I had with somebody last week at Laser World of Photonics, is just realize too, you can't necessarily teach experience. There's going to be a level or a learning curve to any software. We work a lot with folks that are not optical engineers or they don't have an optical sciences background. We see a lot of people because we work with the lighting industry a lot in the automotive industry where people they may be a mechanical engineer, but now they've been tasked with designing a light guide for a new car or something like that. So they don't have that formal optics background. So there's a little bit of training to use the software as well as training, some optical design basics. Things like don't use point sources. They don't exist. Or some of the properties we allow people to apply in software don't exist in the real world, but they're there for certain specific reasons. But yeah, so again, yeah, my biggest one I said, don't be afraid to try stuff. Software lets you try hundreds or thousands of things quickly. You find out what works and doesn't work, and then that helps with the other one about teaching experience. It lets you build that experience, and you eventually learn to really start to trust the software.
Okay. And is there, in terms of kind of learning as you go, then, is there a question about the balance of efficiency? Should you be worried about how long the time it's taking you, or should you
Um,
think about that first?
I mean, that's always again, that's one you look at, and it could depend on the complexity of the project, the skill or the past experience of the person doing the work. Uh, you also have to be willing, I think, at sometimes to realize when you're in over your head and to reach out. Maybe it's reaching out to the software vendor. It's like, hey, okay, I'm beyond what I know. Do you folks know of somebody I can work with to help me get this knowledge, or can you give me that knowledge? Because being a software side of it, there's always with our support people, there's always a fine line between support and consulting, and we have to be careful about that when what we're able to do and what we can do. So.
Okay. And so, Tom, moving on to you, staying on the sort of integration of processes, how do you think performance degradation in real world operating conditions can that be predicted in a high precision optical system?
Yeah, actually, so this is kind of like tying into the first question that you had, where like, what people should think about when they start, picking software or like think about like integrating software into their process. like I really want to say that like my biggest advice is to not just think about the optics, right? So we talked about this, like, you know, no software, no company sits in an island, no software sits in an island, no function sits in an island. You always kind of have to like talk to other physics or talk to other domains. So my biggest piece of advice is to not just think about the optics, but think about like how do you have thermal effects that you want to integrate into your simulation? Do you have sort of mechanical tolerances? Is there stresses? Electronics factors into this, environmental effects factor into this. So all of this is really like when you pick like a software suite or a tool, think about the co-simulation aspect pretty much from the beginning. And so going back to your second question, it's so how can we make these optical designs a little bit more, you know, how can we make the optical designs prepare for the real world is by integrating all of these effects into the simulation and making them part of the design. So the way to do this is to pick tools that speak the same language. Obviously, right? If there's different languages, you have to translate the data you convert. All of this is manual, it's error prone. So that's really difficult. So have tools that speak the same language, preferably sitting in the same ecosystem. I know that I'm definitely biased, but this is where Ansys really stands out. So we have, like, for example, like let's take an example, like so like a sort of like a what is it? Like an optical payload on a CubeSat, for example. So a CubeSat is a very small satellite that often carries like a camera or a spectrometer to observe Earth or for various other scientific missions. And for those types of systems, sort of those optical payloads, they really when the image quality degrades only like on a micron level, you're already done. Like you already can't use that anymore. So you need to start modeling. You know, you model your orbital heating, your solar exposure, and you do this with like a CFD tool, for example, or with like a thermal desktop tool that we have in Ansys. And then you take those temperature results, putting into an FEA modeler, for example, Ansys Mechanical, that computes how all the various components deform. Those component deformations you can then load into the optical design tool that we have at Ansys called Zemax Optics Studio. And with this, then you can finally evaluate the real world performance with all of those effects tucked into it. And because all of this works so seamlessly and without any of this translation, all of this manual effort and the guesswork and the errors, they kind of just go away with this like cross-domain workflow. And you get a fairly seamless and a very accurate final result. And again, this ties into what Dave said, is like you do all of this before you build your first prototype.
That's great. That's a nice answer. So staying with you, Tom, we've already got a question come in here about using Zemax lens design software specifically, and it's basically how you can design a cutoff line for a low beam using the software.
I have to admit, I don't quite know what that means. I will have to get back to this. Like, feel free to contact me, or I can follow up with this question another time. I don't quite know what that question goes as, but happy to answer this when we talk about this a bit more.
Yeah. That goes to anyone as well. If you kind of have any questions that you don't get to answer or we don't get to ask them, then do send them in and we can go through that later.
Sounds good.
So moving on, so Chris, on to the next question. So talking more specifically about your individual work, VPI Photonics wants to help users get the best out of their optical applications and processors. Tell me about how your software suite interacts with third-party simulations and design software.
Yeah, good question. Maybe just to just give a brief background. I know VPI Photonics, our software is a little bit different than the others in the room. We're more focused on optical communication systems and photonic integrated circuits. So we have a number of different tools as well. We do touch on these different levels of abstraction. So I'll give you a quick example. You know, at the very highest level, we have software for designing full fiber networks. You know, so full optical fiber communication networks. That could be core metro networks, but then we also have system level tools. And so all of our tools really are integrated together. So if you want to investigate one link in that full fiber network, you can click it, you can export it to our system level tool and start to investigate it in more detail. So now you can be looking at like a transmitter, the fiber, receiver, digital signal processing elements. And then we have component level tools. So let's say you want to investigate that transceiver in a little bit more detail, and it leverages a photonic integrated circuit inside of it. So maybe a laser and a modulator together. You can easily, in the same interface, dig deeper into that transmitter and start looking at the photonic integrated circuit components and maybe optimizing and tuning those. And then we even get into device level software for like beam propagation method. How does light propagate through a waveguide? So if you really need to extract some parameters for your pick, you can do that as well. But that's really, the full stack of tools. But again, yeah, I guess kind of leaning on what Tom was saying about having the tools being interoperable, covering different domains. That's something that is critical. And so what we do, the way we approach that, a lot of this comes from Python and MATLAB co-simulation capabilities. So we do two different things. One is you can basically import your own model from a Python or MATLAB script, and we have building blocks in our software that make that really easy to do. So you can just point to your script, make sure the inputs and the outputs match the software, and you can really customize the software and do your own, create your own models and bring them in. You could also drive our software from Python or MATLAB as well. So VPI Photonics design suite could be used in the background. So there's a few different ways that we can approach that, and that makes things really flexible. So it can really be used with pretty much any software. Maybe a couple examples in particular. One is that as photonic integrated circuits are being used more and more in data centers, right? They're getting used deeper and deeper into the racks. And the electronic components and the optical components are getting closer together. Now they're starting to interact, and the physics affect one another. We partner with Keysight, so with Keysight ADS. So we have our own electrical models in the software. We support, Verilog A SPICE simulator as well. But if you need something more advanced, then we can go to our partners. And so this type of interface is actually used with Keysight ADS, where you can design so it's one of the EDA vendors. You can design the electronics and then have an optical building block in your schematic. And then our two softwares are dynamically communicating. We do something similar with CST Studio as well. So if you need to really get into the multi-physics simulations and bring those in. And then lastly, I think that maybe the part we haven't touched on here is being interoperable with lab equipment. So that's something that's pretty unique in that we do have an interface for waveform generators and oscilloscopes. So you can really generate a waveform and simulate a waveform, in VPI Photonics design suite, and then export it to a waveform generator, so an AWG. And then you can actually use the physical waveform to drive your optical hardware and see how does this impact the actual hardware. And so getting the two worlds together of simulation and the lab is also very important. So when you do go start buying equipment after you run all your simulations, you can start to validate things, enhance your models. Maybe the models are missing something, and really start to refine things. So that's something else that we also can bring to the table is this getting the lab gurus together with the simulation experts and bridging that gap seamlessly.
Yeah, I guess that kind of ties into what Tom was saying earlier about sort of making sure it applies to real world situations and real world systems as well. And Dave, tell me about some of Lambda's software platforms and what advantages they can bring.
Sure. Well, as I mentioned earlier, we're a little more on the geometric ray tracing side of things. So kind of classical lens design, illumination analysis, stray light analysis, topics like that. And we have three products we make: Trace Pro, Rayviz, and Oslo. Trace Pro is our non-sequential ray trace design software. It's a great tool for, this is me putting my sales hat on so for temporarily, but for very strong in the stray light analysis field. Used in quite a few of the space telescope applications, other types of areas where stray light, or as I tend to call it, unwanted light. When I'm first trying to teach somebody about stray light, this is light that could scatter off of a mirror, and it reduces your signal to noise ratio or degrades your image quality. And these are things you want to really control. So very strong in areas like that, or illumination, whether it's light guides, display applications, things like that. Rayviz is a plugin we use because we found a lot of our engineers that we were working with were working in SolidWorks. So we offer a plugin to do some basic ray tracing in SolidWorks. There's some limitations to doing ray tracing in CAD programs, but we try to overcome and do what we can there. But Rayviz gives a nice seamless integration for somebody working in, say, SolidWorks to bring their models then into TracePro to take advantage of the tools that are there. Biggest difference there is with TracePro, we can do full multi-threading for ray tracing, which is very important. The more processors you can throw at the problem, the faster you're going to get your answer. And Oslo is our more traditional, not typical, but our traditional classical lens design software. And we've tried to keep them separate to the most point because it lets each tool do what it does best. We keep the sequential ray tracing in one program, mostly the non-sequential in the other. There are some overlaps. So our sequential ray tracing program can also do some non-sequential, and we're starting to add some sequential to our non-sequential. But they're still allowed us to design from the beginning as a sequential lens design tool or as a non-sequential optical analysis tool. So there's some advantages to that, but there's also some advantages to that interoperability and that family of products that start to work together. So, like I said, we tend to focus on those three parts of it, those products there, and then sometimes we do have to recommend we can output files or we can bring in other information from other platforms that are third party type things. There's a couple ones we're working on that we hope to be rolling out here fairly soon as well. To bring in that information from these third-party programs into there and then take advantage of the ray tracing and the analysis tools that's in programs like Oslo or TracePro. So we've stuck a little more right now with that, let the separate products do what they do best, as opposed to the Swiss Army knife type of, and no offense to the Swiss Army, but the Swiss Army knife type approach where one single tool does it all. And I don't think anybody really necessarily does that either. I think that's kind of common. There's a lot of specialization in some of the software.
Right, and staying with you, Dave, and touching back to something that Chris mentioned earlier on about the importance or the inclusion of training, in terms of budding optic designers who have the opportunity to close their knowledge gaps and prepare themselves to thrive in the industry, is training a big part of your offering as well?
It is, yes. And actually, it's funny because I've found my position or my role kind of transitioned, from when I was an optical engineer at my previous company to almost, I like to think of myself as more of a teacher now. That I'm on the pre-sale side of things, and I handle a lot of our training classes, especially for our non-sequential product, TracePro. But yes, teaching and training is really important, I think, and it would be a very rare individual that could look at a software package that they're not familiar with and pick it up, in an instant and, be off and running and being productive. There are some similarities. If we looked at lens design programs, if you're familiar with one lens design program, well, with a little bit of pecking around and a little bit of practice, you could pick up another lens design program or a third one. And it's the same with some of the non-sequential tools. Some of the basics are the same, but the actual implementation is different. So we try to look at training in two ways. One is the actual software training. How do you use our tool or tools? But the other that ties in a lot of that is also bringing people up to speed in some of the optical concepts. The concepts of optical design, optical engineering, the not necessarily the how do you do something, but the why do you do something is, and that from a teaching aspect, that's a way we can differentiate a little bit from, say, a technical support side of things, where most technical support is going to be able to tell you how you do something, but they're not necessarily going to be answering the why should you do that? Why should you pick BK7 over B270 when you're making a glass for something, making a lens, picking a glass type. So as I said, a lot of training I've done in the past 15, 16 years now has been, at companies where they don't have the dedicated, optical folks, and then you can then bring in not only the software knowledge, but the ability to kind of sprinkle in a little bit of real world or, past experience type stuff to get them pointed in the right direction. But just knowing, those classes aren't substitutes for formal optical training if you really need that level of skill.
Yeah, maybe to add to Dave's point here, maybe some advice for the participants in the room is you can often find training opportunities alongside conferences. So I know we run workshops, so usually like a 4-hour workshop, sometimes at OFC. We're going to be doing one at ECOC, the European Conference for Optical Communications, later this year. But also online training. So if there's a specific tool, go check out the website, pay attention to the marketing of the different software vendors. But this is really key, because I'm finding, with our user base, they're having trouble finding engineers who can run different software packages. So there's a shortage of optical engineers, especially for specific use cases. So if you're trying to grow, and you're going to a conference, I would definitely recommend trying to find a learning opportunity. And then we're all going to be running, I'm sure, virtual training. So I know we run 2 sessions each year, 2 like full open training sessions, one in the spring, one in the fall. So that's definitely, especially if you're trying to grow in your career and trying to find new opportunities, might be something you do on your own, might be something that your company might sponsor. But definitely highly recommend it, because the learning curve in these softwares, it's pretty steep. And once you get into it, then you start realizing, oh, okay, well, now I need to know this thing and this other thing. And so really, like, some people often think about skipping like the basic training, like, how do I use the interface? Real basic things.
It's also really
Exactly.
nice when you do a training, especially when it's like multiple people, or you attend like a few webinars, or like, say, like virtual like sort of courses, that like every teacher has like their own favorite features. And like with like general software tools, there's so much on offer that, like, getting those like little tips and tricks and like, workflow, little, just like the little quirks, it's just really nice. And then on top of that, especially like, as the industry like evolves, you kind of want to keep up to date with this. You do need to keep training, and like, especially when it's like a new application area, figuring out how to do a certain new thing is kind of like, you kind of have to keep up with that.
And that's one thing too that I realized we switched over with COVID to a lot of online training, as a lot
Yes.
of people did. That as a part of my job being teaching, I miss the in-person training.
Mm-hmm.
Whenever you can do an in-person training or attend an in-person session, there's so much more to be learned,
Mm-hmm.
because one thing I find doing it, online training is you can't look at the room and read the room. It's like, what I just said, is that going like straight over somebody's head, or, the glazed eye look? or there are a bunch of nods going on. It's like, yes, I get it, things like that. So that's when folks are looking at deciding between in-person versus online training, that's one thing that's missed, is that interaction between the instructor and the student. There's also, I always like to plug too, there's great networking opportunities when you go to an in-person training. Uh, Mentioned Chris's point about conferences. A lot of training I went through before at my previous company was I would go to a show, like SPIE optics and photonics, and I would go just to go to the training classes. I would walk the floor quickly, and I hate to say this, being now as a vendor that's at the conferences to talk to people. I was one of the people the vendors didn't necessarily like because I would just breeze through, take a look at the booths, and then I was going back to the next training session. But that's a great any of these conferences to learn from, some of the experts in the field, on these different subjects. And you can, a lot of different subjects. I remember one I was at where I went to a 4-hour class on light guides, another class on hyperspectral imagers, and another class on lens design. So all within one thing, I got these 3 little, half-day courses where, learned quite a bit of stuff from that.
And staying with the sort of the training platforms, where do you draw the line in terms of balancing between the simplicity or the intuitiveness maybe and the complexity in terms of the features of software? Is there any line? Is there any kind of way that you kind of draw back on not making things too kind of complex, or do customers always want to be able to do more?
I think you kind of have to this is such a boring answer, but you kind of have to do both, right?
Yeah.
So you kind of have to be able to do like these advanced simulations. I don't know, I've mentioned this already, all this like thermal effects, all of that stuff. Like that's just advanced simulation stuff, right? And you want to be able to do that on top. You want to do on the one hand. On the other hand, like more and more people do optical design that definitely do not have an optical background. Like, I myself come from the high energy physics area, so I like particle accelerators, definitely not pure optics. So therefore, this is sort of making the tools usable by people whose domain is not necessarily optics is very important. This whole like shift left, like slogan is a big thing. So making user interfaces intuitive, and it's not just scripting. Obviously, scripting is important, but like the graphic user interfaces, making them intuitive, giving people tools that have a bit more of a smarter design that help them explore spaces a little bit more obvious, give them the information that they need, and not just having to read through 50,000 plots and making their own conclusions is really important for faster results. For people who are not coming from the optics.
Yeah, there's a few ways, right, to get started in the software. Usually it's like there's the documentation, there's a getting started, some tutorials, you do that on your own. Some people like to operate that way, but I think as Tom mentioned before, if you start interacting with the vendors, they operate the software their own way, their own personal way, and you pick up tips and tricks along the way. I think when you get, James, to the point of, okay, what level of complexity do we operate at? We offer a comprehensive training course, and it's, the curriculum is pretty much set in stone. We know what we're doing, and it gets you through the basics. It gets you into some level of complexity. But if you really want to go to the next level, then that's when we would offer like private trainings. And so at any time, you could reach out probably to any of us and say, hey, I really want a private training, but I really want to focus on these 3 topics. Can you come up with something? And, we like to stick to our templated training topics, but we usually have examples pretty much, ready to go. Just have to build a little bit around them. So that's something that we'll do with our more advanced users is set up private trainings. That way they can ask questions without worrying about others in the room, stealing their IP or being private about it, right? They can ask more open questions and focused with the curriculum focused directly on, hey, I want to learn about, coherent transceivers or something like this.
Yeah. Yeah, and we do a very similar model as well. We have our set classes that we offer. They're open to the public. Anybody, whether you have our software or not, can sign up for them. But then we do offer that other level of that private training. And what I like to do myself is with the private training is sometimes a customer may have a specific model they want to work on. So, we can have the flexibility in a private training like that where we can, we can do NDAs and things like that so we can see their examples and we can use that as the base. We can say, okay, here's how you would, here's how I would analyze that. And then they can start to add in their own points of view and what they're looking for. So I've always enjoyed those private trainings, whether it's on our site or a lot of times they're on the customer site, because it also allows the customer to invite or bring in, 8, 10 people at a time, as opposed to, when we used to do public trainings and, in a fixed location, now you have the expense of people flying in for that or traveling to that. So being flexible and, I think you're saying be able to read the room, it's always good. It's always good to have a trainer that's worked with the software quite a bit as well. I think that's always a plus.
Great, thank you. And moving on, so in terms of more complex optical assemblies, and this maybe Tom, you can answer this one. What are the main limitations engineers tend to encounter when they use current optical design software tools to model multi-physics phenomena? And can you give any examples of those? Sorry, you're on mute still, I think, Tom.
Sorry about that. It had to happen at some point, right?
Yes.
Yes, we touched on this a little bit in the beginning. So obviously, multiphysics is, as I mentioned already, is a big thing, right? You kind of want to co-simulate a lot of things. One of the most recent advances that we made is that we can now model like stress induced like birefringence in our optical code, which is something that is an effect that that is like affects like more complex, like quite complex systems, also like thermo-optic effects. So basically, the thing to model these things is always quite complex, right? But then also like taking those complex models and bringing them together is never really historically hasn't been very easy. And now we're making this a lot easier with getting these things integrated into one platform, like being like Zemax Optics Studio. So you can import these like so these stress birefringence effects, for example, those are modeled. So these stress effects are modeled in an FEA modeler. Then you bring them in, and then you analyze these stress birefringence effects directly in your optical tool, like you do all your other optical simulation, like your ray tracing, your optimization, and so on. And you can map these stresses that come from the FEA modeler to, for example, like local refractive index changes, and then how that affects sort of the polarization results, and therefore how the image quality ultimately degrades. Again, this used to be super manual. Now it's for the most part integrated, and again, that makes this whole thing a whole lot easier to do. What I have to say, though, these things, just because they're integrated, doesn't necessarily mean that these things are easy to understand. They're still very complex physics domains. And some of these workflows, even the ones that are integrated, or like, for example, even when they're integrated, especially when it's a more niche use case, they can still be quite involved. So again, here, we mentioned this earlier, driving software towards easier use, closing that gap. So for people who don't necessarily understand all the ins and outs of FEA, of CFD, all of these difficult physical domains for an optical engineer, like making tools that like make it easier for them to understand that and to like integrate that is really important. So for people who are not FEA experts, for example.
Thanks, Tom. Thanks for that. And I mean, just before we move on to our final question, the Q&A board has lit up across the web panel. I think.
Yeah, I've been trying to keep up that.
Answered them already, Tom, but just to go through some of them here, if anyone feels able to answer any of these. So someone asks if there are any softwares that offer the simulation of moderate to high energy laser sources, and the modeling of optical systems with the stochasticity in either power, beam profiles, or phase wavefronts due to high or moderately high optical powers. Is anyone able to?
Yeah, I can maybe answer that. I guess I don't really know exactly what you need here, but we do have an offering at VPI Photonics for high power fiber laser design. And so actually, I don't know if this addresses your interest, but it's really to do physical modeling of a doped fiber laser. So erbium doped, erbium, ytterbium, co-doped fiber lasers, where you can specify like the doping profile, the doping concentrations, and actually model the energy transitions between the different levels. And so this is being used for a few different use cases, one for long haul fiber communications, but also more recently for laser satellite communications. And then high energy lasers, of course, for industrial applications or defense applications. So we do have some, that's basically just for fiber lasers though. But that's something that we offer.
Thanks, Chris. Taking that one. Yeah. So the next one we've got here is so when simulating scattering effects at surfaces at surface level, sometimes it's not actually possible to get measured scatter data from specific surfaces, such as those which are hidden inside a structure. So what's a good approach to get the best approximation of those?
That's a really good one. And I do scatter measurements from time to time, so I always stress the importance of good scatter measurements, uh, especially surface scatter. It's one of the areas we tend to do. I think we do a very good job at modeling that type of scatter. It is I don't know if there's an easy or a good answer to that one. My first thought would be to try to get an external sample to be measured. Measure for BSDF, bidirectional scatter distribution function. Uh, and then from there you can work with you can create properties that can be used not just on our software but other programs. I think most of the other geometric type optic codes are going to work with BSDF scatter profiles. But the other thing that I've done in the past, especially with larger scale type scattering surfaces, is to make a 3D model of it, do some ray tracing, do some scatter analysis like that. And from there, you can create a scatter property that would allow you to apply that to, say a curved shaped surface or an irregularly shaped surface. Uh, there are also some tools if you have any information on like surface roughness, RMS roughness, where especially when you are at the sort of at the micro level where you're down couple wavelengths of light type distances and sizes for the RMS, where you can convert an RMS value to a BSDF value or a scatter value. But there's not an easy answer to a question like that. Usually the simple one is measure, 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 but you can't always do that. So, but good question too. That's a good one to think about.
And the one thing is like, if you can't measure yourself, like I want to say most optical tools that do scatter analysis or do stray ladder analysis will have extended scattering libraries built in. So you can find, I don't know, maybe talking to the vendor, like find similar scatter functionality already there.
Yeah.
It's reaching out to like a customer support with a software to like discuss the problem, right? Like people will have experience in finding at least something similar. There's also analytical models in all of these tools where you can, I don't know, there's what type of scatter distribution function, an analytical one that you can use. So I feel like there's stuff there, but obviously, as Dave says, measure is always best because the more you measure, the more real data you have in, the more realistic your system will behave.
Yeah. Yeah, and that's a good point, Tom, as well as like sort of the associative property. Find something that's close. It may not get you the exact answer, but hopefully it gets you in the ballpark where you can start to see is that really an issue or not, and then go from there. But, yeah.
Yeah. Thank you for that question. The next one is specifically about ANSYS Speos. And it's that when the person asking the question designs optical parts using the software, the part becomes a dummy element, which means there's no trace of the design history. And when they do it for automotive light design, a lot of iterations are involved. So they need to keep the design history. Do you have an update on that function, maybe?
Yeah, so design tracking or like sort of like version control is a big thing. There are some tools out there that I'm personally not. I mean, I'm somewhat familiar with Ansys because it's part of the Ansys Optics portfolio, but my tool is Ansys Zemax, right? So I can only speak from the Zemax point of view. So for Zemax, we also don't have versioning. Again, we're running into the same issue where people say, like, look, the design is, it's sort of like the only way that people currently do versioning is with like lots of annotations, like commenting and that type of thing. What we do have though is that our design files are text-based, so you can check in those like ASCII files or ASCII files into a GitHub, for example, and it's like Git tracked. So that's sort of like my workaround. It's not ideal. We are working towards having versioning at some point similar to how, I don't know actually what it's called, but all the CAD modelers have versioning because obviously they're not text-based. But yeah, so we are a little bit behind on this, but it is definitely something that we're considering.
Right, so more to come on that. So keep updated on that. And so moving on to this is a more general question, I think. So kind of anyone can feel free to jump in on this one. And it's what do you think about the subject of introducing AI into optical design?
I think that's a really, really big topic. It's really important to like that we embrace this and I'm not scared of it, right? So it's so AI is, I think, like, because we like systems becoming more and more complex, right? For example, miniaturization is a big topic at the moment. Stuff gets smaller and smaller, tighter and tighter package. Therefore, it's more prone to have tolerance errors. They're just like, it's just more complex systems, more complex problems to solve. How do you do this? Well, AI could help with this, right? So, for example, you could have AI help you with having really smart choices to start your design with. You can have AI to help you with like exploring your design space, or to like, making trade-offs. What if I happen to tweak it here? What happens there? Can AI do all of these evaluations by itself? And then also like maybe figuring out what are potential issues down the line. Using AI to enhance your tolerancing methodology. There's a lot of things that like help you with this. And again, this goes back to what I mentioned earlier. All of this stuff really helps people who are not experts to still do good designs and buildable designs. Again, market, like, it's because more and more people work on these systems.
Yeah,
it's a good comment too. But go ahead, Chris. I'll jump in afterwards.
All right. Yeah, I was just gonna say. We're kind of embracing AI two different ways. One is that our software actually enables AI data centers. So I don't know if you guys saw, but in the latest NVIDIA GTC, Jensen Huang announced the use of integrated photonics in their latest networking switch inside of the data centers. And that hits a topic that we support directly, right? So what people need to do are design a custom photonic integrated circuit that's being used in an optical communication center inside of the data set, or optical communication system inside of the data center. And that's what our software enables and allows researchers to do. So one thing is that optics is enabling AI, which is pretty cool. And then the other part is we do have we call it a machine learning framework in our software. And this is kind of it's kind of interesting because you can develop your own neural network model. So we basically wrap a user interface around a lot of the machine learning tools. So you can develop your own neural network model. A lot of people don't want to do that though, right? Because it's not always physics informed, right? You can run a bunch of simulations and generate your training data, and then you have some model that does something. Okay, that can be useful in certain cases where maybe you don't have a physics model for something and you just need something. Another part that I find actually really interesting is for areas where you do have a model for something, but the simulation time is very long. Maybe it's a very physical model. And so if you're running simulation after simulation, this starts to add up. So one thing you can do is, create a training data set through simulation and then create a neural network model for that very advanced physical model, and then use that going forward. And then I think that's an interesting use case just for speeding up your simulation times so very advanced types of modeling.
Yeah.
But yeah, sorry, Dave. I didn't mean to cut you
no,
off.
No. I think I jumped in there in front of you. So same. So good. Because your comment there about the building like almost a learning library type thing there with the AI. There was a good talk I heard on that last year at one of the SPIE shows of for illumination systems, which can get to be quite complex, and the solution space is very large for some of these solutions. So designing more of a machine learning type thing, but it involved a whole bunch of ray trace examples that took a lot of time to develop. Then that AI or machine learning system could then use that so that you could basically start at the end and get to the with the result, and then come up with something in the beginning. But the one that I wanted to mention was Tom's comment about buildable systems. That's one thing that I always caution about when I do trainings, and that you see as well, is that all of the software, I'm assuming most of our software, allows people to build systems that could never be built. I've seen some very interesting like IODC designs from the lens design competition where you have like almost mile thick lenses. They're weighing in excess of 300 tons and things like that. So you do have to have that ability to filter out those non-manufacturable designs. And
I feel
I did a oh I was
I
just
also
gonna
feel
say
sorry,
yeah
I feel just like all patent registers are full of designs that can't be
yeah
built, right?
right. I remember seeing an early patent one time. Somebody had it was for a flash system where they had a flat piece of aluminum reflective material and a strobe light in front of it, and they attempted to patent that. So sometimes they could be blatantly easily to manufacture, but they're also blatantly obvious to
Fair.
anybody that has any knowledge. But yeah, but AI, you're right. It's there. It's an existing tool, and I think you need, from my take on it, because our marketing people use AI to generate a lot of marketing materials, that you just have to realize it's a tool. It's not, it still needs to be, I find it still needs to be checked by somebody with some knowledge and some experience. I found a lot of the AI written articles I've seen tend to overreach and overstate capabilities and things like that. So there's always going to be, at least I hope there's always going to be, the need for somebody to be in control of that and be the reality checker there. But it's a pretty exciting new field, and it's been amazing how quickly it's come along, really, in just the last few years. But I think there are some applications for that. You mentioned there's the comment there about long ray tracing times. I saw a talk last week, and somebody mentioned for a certain rigorous model of a meta surface would take, in current technology, about a 2 million year ray trace for that. So I was rather floored by that it could actually take that long. But um, so yeah, so it is a good tool, but I think just to remember, it is a tool, and it's another tool in the toolbox, to use the cliche, I guess.
Yeah, we try to be a little careful about actually using it internally as well. In software development, we have a policy not to be using it, just because we don't want to cause any IP related issues,
Yeah.
right? If the AI is trained on some proprietary data that we're not aware of, then we would be
Yeah.
liable for this. So we
That's
gotta
an
be
interesting one.
Yeah, we got to be careful on our end too. And so, yeah, for our software development, we're not using it.
That's great. That's really kind of round answer about AI and machine learning. And that's great. I think we've got a few more questions that have come in, but I might put those to you in an email, and we can get some answers out to them later on. And move to our final question here, which is, how much do you think these common optical design challenges will evolve in the future? What kind of challenges will there be in the future, and how can the software itself evolve to solve them? Um, Anyone can kind of jump in on that as you wish. Yeah.
Well, I'll go first. I think that they're going to have to continue. The tools are going to have to continue to evolve because the problems and the design tasks are just going to get more and more complex. The level of integration is going to increase. You know, it's not going to go back to a Galilean type telescope where you had one or two optical elements and that was it. You know, the end user was your eyeball. So the complexity of it's going to increase, and I think the need for solving these problems. You know, I think just an example with the problems that the Hubble telescope ran into, you know, those were fixable because it was at low, you know, relatively low orbit. You get into James Webb, it's like if there's an optical design problem in James Webb, it's not being fixed. So the the need for that ability and the I guess the risks that happen with not getting things correct, you know, like I said, working in that type of environment, but that's the same thing in other ones. And also the tools will, I think, continue to develop because the speed of development is going to increase. And that's a big area where any type of simulation tool I find is great, is in the speed of development. Get products to market, which is ultimately what all our customers are trying to do. Get a product to market, deliver it to the customer, and get paid in rather simplistic terms. But
Right.
that's the ultimate goal.
Yeah, I
Yeah.
think yeah, from my perspective, this kind of ties back to what I said in the very beginning is, you know, do you have an internal team developing your own software, or do you work with commercially available software? And one of the things that maybe isn't as appreciated is, you know, as a software vendor, we're spending a lot of time, you know, figuring out where the market is going, where the industry needs, you know, we're talking with multiple users, multiple customers, and getting feedback and building that into the software. So one of the risks that we're taking is that, you know, in software, we have to be a couple years ahead of the research so that when the researchers are working in this space, you know, they have the tools available to them. They're not waiting. So we take a bit of a risk in developing those tools, kind of looking ahead, looking around corners. Where is the market going? Where's the industry going? And not just paying attention to the buzzwords, because yeah, sure, we can focus on all types of different quantum applications, and we do, you know, we have developments there, but those are the types of things where, you know, if you don't have one foot on the boat when it takes off, you're too late. So we have to pay attention to those things, but we're making the decision of where are we really spending our time and effort and developing new features. You know, that's what we're doing as software companies, and we're building those in with every new update, every new upgrade. So it is a constant evolution of, you know, new capabilities. I'll give one example, is we spent a lot of time the past couple of years developing software simulation solutions for laser satellite communications, so free space optical communications. And that's something that we took a bit of a risk. We saw, okay, yeah, there's definitely a need here. We're getting people asking about it as well. Let's get some basic capabilities into the software. We did that. We got a lot of good feedback, a lot of good requests. And so then we started building those requests, those new features into the software. And so we really evolved over time. So that's something, yeah, all the software vendors are taking this risk, trying to look around corners and build those new features in.
Yeah, I don't really have anything to add. I agree with both of those. as I said, it's like as Dave already mentioned, stuff's going to be more integrated. It's going to be more and more automated, and it's going to be smarter. I feel like though, like we just have to continue that train because systems are just going to get more complex, and there's just more pressure on those systems and then the performance of them. So I feel like that's the way to go.
Right. Well, thank you for that, gentlemen. I think with that, we're almost up with our hour. So any of the remaining questions that we've had, I'll send out to you and get the answers to anyone who's asked them. But as I mentioned earlier, the discussion will be available on demand in the webcast section of the Electro-Optics website to hear again. And also send in more questions are still coming in, so to send us your questions as well over the next 12 months. But now we're just into July, the Photonics 100 panel discussion series. We're entering a little summer break period, but we'll return on the 3rd of September with the next web panel, which will be Photonics in Environmental Monitoring, Challenges and Opportunities. So make sure you register for that one to find out which way the wind is blowing there. During that web panel, we'll be speaking to William Curtin, project coordinator of the Part 2 project at Munster Technological University, David Blair, who's Vice President and General Manager of Remote Sensing at Headwall Photonics, and Dave Nelson, who's President of Aerodyne Research. But until then, I'd just like to thank today's guest speakers, Tom, Chris, and Dave, for joining us and lending us their insights for an hour or so. Thank you, gentlemen.
Thanks so much for having me.
Thank you.
Yep. Thanks,
Thank you
everyone.
for organizing. Thank you.
Thank you.
And thanks to everybody that attended as well.
Goodbye.